In this video, we are going to study how we can transform the curves of y equals fx to y equals afx, y equals fx plus a, y equals fx plus a, y equals fax, y equals minus fx, y equals f minus x, etc., where a is some real constant. We are going to see how we can do these simple transformations by making slight changes in the original curve of y equals fx to curves of these various forms. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Here we will see how we can transform a curve of y equals fx to y equals afx. Here y equals x plus 1 is original straight line which can be plotted by putting first x equals 0, so y becomes 1, and after that by putting y equals 0 so that x becomes minus 1. Now by joining these 2 points 0 1 and minus 1 0, we can sketch this curve y equals x plus 1. We can also sketch straight line y equals 3 times x plus 1 where scale factor a is 3. Again by putting x equals 0, we get y equals 3, and by putting y equals 0, x equals minus 1. By plotting these 2 points and joining them, we can sketch curve of straight line y equals 3 times x plus 1. This we can do directly by moving y coordinate 1 parallel to y axis by scale factor a, which in this case is 3. If the scale factor a is negative 3, then we have to move parallel to y axis downwards. In both these cases, the point on x-axis minus 1 0 remains the same. Next we have to see simple transformation of sketch of y equals sine theta to y equals 2 sine theta where scale factor a is 2. In the original curve of y equals sine theta, sine pi by 2, which is 1, for the curve of y equals 2 sine theta becomes 2 times sine pi by 2 parallel to y-axis. So this top point moves from 1 to 2 according to the scale factor a equals 2. Same thing happens with sine 3 pi by 2 where sine 3 pi by 2, which is minus 1, becomes this minus 1, and according to scale factor 2 sine 3 pi by 2 becomes this minus 2, and movement of top point from minus 1 to minus 2 happens parallel to y-axis. In the sketch of y equals 3 sine 2x, scale factor a is 3, so 3 sine 2 times this pi by 4 becomes 3 sine pi by 2, which is 3. So the top point has moved from 1 to 3 parallel to the y-axis. Similarly, 3 sine 2 times 3 pi by 4 becomes 3 sine 3 pi by 2, which is 3 times minus 1 minus 3. Hence, the value minus 1 from here is shifted towards minus 3, again parallel to the y-axis. Next we will see simple transformation of curve y equals fx to y equals fx plus a. Here we can see y equals fx is shifted by a units parallel to y-axis. Accordingly, the straight line curve y equals x, which passes through origin, by simple transformation becomes y equals x plus 3 by shifting y coordinate of origin 0 3 units upwards and x coordinate of origin shifting 3 units to the left. In case of transformation to y equals x minus 3, this shifting would have been 3 units downwards parallel to the y-axis. In fact, these three lines y equals x plus 3 and y equals x minus 3 have same slope, hence they are parallel. Simple transformation of the curve y equals cos theta to y equals cos theta plus 2 can be obtained from cos 0 equals 1 to cos 0 plus 2, 1 plus 2, that is 3, shifting parallel to the y-axis. Similarly, transformation of cos pi here, which is minus 1, to cos pi plus 2 minus 1 plus 2, that is 1, happens parallel to y-axis. In the first case, the point moves 2 units upwards from 1 to 3, and in second case also the point moves 2 units upwards from minus 1 to 1. Simple transformation from y equals x square to y equals x square plus 3 can be obtained by shifting the vertex at 0 to 3 parallel to y-axis. Simple transformation of the curve y equals x cube to y equals x cube minus 8 can be obtained by shifting the curve 8 units downwards parallel to the y-axis. Obviously, for the new curve y equals x cube minus 8, when y equals 0, x will be 2. So 2, 0 lies on the new curve. Similarly, when x equals 0, y is minus 8. So 0 minus 8 also lies on the new curve. In simple transformation of the curve y equals sin x to y equals sin x minus pi by 3, the curve is shifted pi by 3 units parallel to the x-axis, because in this transformation there is direct change happening from x to x plus a. So the point on the curve y equals sin x, which was at origin initially, got shifted along the x-axis to pi by 3. The rule states that when this a is positive, this shifting along the x-axis is in the negative direction along x-axis, that is to the left, and when a is negative, as in this case minus pi by 3, this shifting is in the positive direction along x-axis, that is to the right. You can also see this top point on y equals sin x getting shifted pi by 3 units, and this pi to this point 4 pi by 3 to the right along the x-axis. Please note here that the shape of the curve is same, only it gets shifted along the x-axis according to the sign convention of a provided here. Simple transformation of the curve y equals x cube to y equals x plus 2 whole cube can be obtained by shifting this 0 to minus 2 along the x-axis. This is because a, which is 2 here, is positive, so the shifting happens to the left. In simple transformation of the curve y equals x square to y equals x minus 4 whole square can be obtained by shifting this 0 to this 4, which is a, to the right along the x-axis. This is because a in this case minus 4, which is negative, hence the shifting happens to the right, the shape of the curve remaining the same. Simple transformation from the curve of y equals sin x to y equals sin x plus pi by 4 can be obtained by shifting this pi to 3 pi by 4 to the left, this 2 pi to 7 pi by 4 to the left and this 0 to minus pi by 4 to the left along the x-axis. And this shifting happens to the left because a in this case is pi by 4 and it is positive. The shape of the curve remaining the same. Simple transformation of curve y equals x square to y equals x minus 1 whole square can be obtained by shifting vertex 0 of curve y equals x square 1 units to the right along the x-axis. This is because in y equals x minus 1 whole square, a equals minus 1, which is negative. Similarly, transformation of the curve y equals x square to the curve y equals x plus 2 whole square can be obtained by shifting the vertex 0 of the curve y equals x square to minus 2, that is to the left of 0 along the x-axis, and this is because here a is 2 and it is positive. Before we understand simple transformation from fx to fax, let us understand one thing, that for every point x1 y1 on the graph of y equals fx, there exists a point x1 upon a y1 on the graph of y equals f of ax, where 1 upon a is the scale factor for x coordinate. So, simple transformation of the curve y equals x minus 1 whole square to y equals x upon 2 minus 1 whole square can be obtained by stretching the curve y equals x minus 1 whole square parallel to the x-axis by a scale factor a equals half. So the curve is stretched in the ratio 1:1/2, that is 2:1. We can obtain vertex of the new curve by putting y equals 0. So x upon 2 minus 1 will be 0, giving us x equals 2. Therefore, the vertex of the new curve lies at 2, 0. You also can see the new curve has been stretched twice as much along the x-axis. Here, simple transformation of the curve y equals cos x to y equals cos 2x, where a is 2 and hence the scale factor 1 upon 2. This transformation can be obtained by shrinking the curve half its size. So, for one loop of the curve y equals cos x, we get two loops of the curve y equals cos 2x. Simple transformation of y equals sin x to y equals sin 2x can be obtained by shrinking the graph of y equals sin x to half its size for the graph y equals sin 2x. Therefore, for one loop of the curve sin x is transformed to two loops of the curve sin 2x. Simple transformation of y equals e raised to x to y equals minus e raised to x can be obtained by reflecting graph of y equals fx in x-axis. So here you can see graph of y equals minus e raised to x as a reflection in the x-axis of the graph of y equals e raised to x. Simple transformation of y equals x square plus 2 to y equals minus x square plus 2 can be obtained by taking reflection of y equals x square plus 2 in x-axis. So here is curve of y equals minus x square plus 2 as a reflection of the curve y equals x square plus 2 in the x-axis. Simple transformation of the curve y equals x plus 2 whole cube to y equals minus x plus 2 whole cube is obtained by reflecting the curve of y equals x plus 2 whole cube in the x-axis You can see reflection of this part in the x-axis happening like this here, and reflection of this part of the curve in the x-axis is happening here. Simple transformation from fx to f minus x is obtained by reflecting curve of y equals fx in the y-axis. So here reflection of the curve y equals x cube to y equals minus x cube is obtained by getting a reflection of this part of the curve here in the y-axis and reflection of this part of the curve in the y-axis here. Here also the transformation of the curve y equals log x to y equals minus log x is obtained by taking the reflection of the curve y equals log x here as the curve of y equals minus log x in the y-axis. Here remember, for a positive value of x we do not have y equals log minus x because log of a negative number does not exist. So we have written y equals minus log x, which is log x raised to minus 1, that is log 1 upon x. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.